This is my introduction. For my project, I chose to teach you how to properly flip a water bottle. To properly flip a water bottle, you need to transfer the momentum from your hand to the water bottle in such a way that it lands upright. This is a proper way to flip a water bottle. Now here's a terrible way to flip it. This one I flicked too much and it went flying off camera and landed on its side. There was too much momentum in my hand, so when it transferred over to the bottle, it rotated too much. When you look at my hand, I apply a certain amount of force or torque since the bottle is supposed to spin, which then creates momentum, and this momentum is carried over to the bottle. This type of momentum is called angular momentum. There are two types of angular momentum: momentum of a point object and momentum of an extended object. The water bottle uses point object momentum because a certain mass, the water in the bottle, rotates around a pivot point, which is the cap. So the momentum that is carried over to the bottle from my hand causes the center of gravity of the mass to pivot or spin around the cap. The reason why it lands on its bottom is that I put just enough force so that the bottle rotates slowly, allowing the water to shift and bring the bottle down and land on its bottom. To further understand this, I will figure out the angular momentum of flipping a water bottle. The equation for angular momentum is L equals R times P. For this, I need the radial distance, which is from the cap to the center of the remaining water in the bottle. I found that the radial distance is 0.17 meters. Next, I need to find the linear momentum, which is P equals M times V. The mass is 0.158 kilograms, and the velocity is distance divided by time, so 0.457 meters divided by 0.09 seconds equals 5.07 meters divided by seconds. Now I'll multiply 0.158 kilograms and 5.07 meters per second to get P equals 0.801 kilograms meters per second. Finally, I multiply R, which is 0.17 meters, and P, which is 0.801 kilograms meters per second, to get L equals 0.136 kilograms meters squared per second. Now I can go a step further and find the angular impulse of the bottle, which is the change in L equals torque times time. We already know that L equals 1.36 kilograms meters squared per second, and the length of time that I apply the torque to the bottle is 0.09 seconds. With this, we can plug these values in and get a torque of 15.1 Newton meters.
Now that you know the physics behind flipping a water bottle, here are some more flips. In this trick shot, you can see that the bottle flips onto a moving surface. To make it land, you need to apply the right amount of torque and force to make it land on the treadmill. With this trick shot, my brother needed to apply very little torque, but more force to make it fly high enough to land on top of the door. It's the motherfucking Eagle Double G. Snoop Dogg! This last flip was up the stairs. To do this, I need to again apply a small amount of torque, but a lot of force. The reason why you have to apply a lot of force is so that there is enough momentum to carry the jug up and over the flight of stairs. This is my conclusion. If you want to properly flip a water bottle, you should flick your wrist and apply just the right amount of torque so that the bottle lands properly instead of spinning it as hard as you can and having it land on its side. With this knowledge, you can do any type of trick shot and flip any type of water bottle.